Assalamualaikum and greeting everyone. We are from Group 2. Today our topic exploring the Snapdragon 835 architecture. So what does Snapdragon 835 mean and function? First of all, let me introduce my name, Nur Shazmina binti Zaini, and my matric number 2023197733. So next.
Hello, my name is Muhammad Ali Fikram bin Muhammad Zaini, matrix number 2023197521. And next.
Hello, my name is Irfan Abdul Azizul Hakim. My matrix number is 202-3367749.
Hi, my name is Ain Zulaika binti Abirau. My matric number is 2023365639.
And last, my name is Wan Nurul Alisha binti Wan Asri. My matrix number is 2023103547.
So let's continue with the introduction. Next slide. Let's continue with the introduction. Back in November 2017, Qualcomm unveiled the Snapdragon 835 in the next major evolution of Qualcomm system on a chip platform, and it's when you will be seeing in a lot of smartphone platform that span all of the company mobile hardware and software. Second, basically every major chip on the 835 is a new part, from the existing light modem to the octa-core Cairo 280 CPU based partly on ARM reference core, the Adreno 540 GPU, the Hexagon DSP, and more. Initially, Qualcomm claimed the Snapdragon 835 would be around 20% faster than the Snapdragon 820, but also capable of being around 25% more power efficient on the same workload. Besides this, the new 10nm fabrication process also brings inherent improvement across the board, literally, especially in efficiency, allowing Qualcomm to fit more transistors into a small die than ever before. The Snapdragon 835 is in fact the first commercially available 10nm SoC on Earth. For detailed information about all the change and new feature, I will pass on the next presenter.
Okay, next, my name is Muhammad Ali Fikram. So I would like to present about ARM Cortex A73. So for overview, Cortex A73 is a 64-bit processor core by ARM Holdings, part of the ARM's 8A architecture, emphasizing power efficiency and sustain peak performance, and primarily target at mobile computing such as laptop, smartphone, tablet, and more. So next slide, I would like to present about microarchitecture. So in microarchitecture, F3 wide decode microarchitectures has fundamentally shorter pipeline stage, mostly due to optimization on the front end. The fetch stage is only 4 stage deep. The decode stage is particularly an element which shortens the pipeline length, as the A73's decoders are able to decode most instructions in a single cycle. The A73 increases its maximum overall dispatch rate from 4 to 6. The reservation station for FP pipeline can stay dispatched 2 into the common neon issue queue. So next slide, I want to explain about features in Cortex ARM73 that have 7 features. And firstly, peak performance, best efficiency, microarchitecture tuned for energy efficiency, optimal pipeline resource and interface trade-off, focus on the best mobile workload performance, optimization including prediction, prefetching, memory throughput, and caching. And last, ideal features for mobile and consumer devices, Charleston Neon, virtualization, and crypto. Secondly, sustaining high memory bandwidth, optimized main TLD for performance, main TLD prefetcher for larger workload streaming to simultaneous page table walks, ability to hit in TLD during PTW. For add-to-catch optimizations, that sustains parallel streams with no performance loss for better multi-core performance scaling, decorrelated cacheable and non-cacheable accesses, enhanced arbitration for interleaving accesses, and improve and smart cache replacement policy. So that's for Cortex ARM73. I will be next presenter. Thank you.
Hello, my name is Irfan Abdul, and I will be presenting you about ARM Cortex A53. So inside Snapdragon 835, we have the ARM Cortex A53. It is a powerful 64-bit microprocessor and the first central dual processing unit part of ARM V8A architecture. It is a big little processor, meaning that it can be configured or be paired with another Cortex A, which in the Snapdragon 835 context is the Cortex A72. That's now that Alif present to you. One of the pros or A52 known for its design is power efficient. Mainly the ARM Cortex A53 is used inside smartphones, tablets such as smartphone Xiaomi 9C, HTM global version new Note 20 Ultra mobile phones. And then next is I will be explaining about execution and pipeline. So the first one is two-way superscalar pipeline. So what is meant by pipelining? Pipelining is a technique used in a computer processor to increase instruction throughput by dividing the instruction execution process into multiple stages. Each stage performs a specific operation on a different instruction simultaneously, resulting in parallel execution. And then the meaning of superscala, which we have a superscala architecture. Superscala is like somehow like pipelining, but is in the same term. Superscala architecture refers to a design that allows multiple instructions to be dispatched and executed simultaneously. In a two-way superscala pipeline, the processor can issue and execute up to 2 instructions per clock cycle. So, in the second point, in order execution with limited out-of-order execution. What is meant by that? In order execution means that instructions are executed in the order they appear in the program. In this type of pipeline, instructions move through the pipeline stages in a sequential manner without any reordering or rearrangement based on dependencies or resource availability. And then there's out-of-order execution. While the overall execution orders is in order, limited out-of-order execution allows certain instructions to bypass others and can be executed ahead of them. As long as dependencies are satisfied and resources are available, this helps maximize the utilization of available execution units and keeps the pipeline busy. Why is a limited term in there? So the term limited suggests that not all instructions can be executed out of order. Instead, the processor employs specific mechanism to identify and execute a subset of instructions out of order while maintaining the overall in-order execution order. So I give you for example here. So as an example, we have first we have instructions A, B, C, and D. So while in order execution, it will execute instruction A, B, C, and D. But we also have limited out of order execution. So with that saying, limited order execution will execute instruction A and B simultaneously, execute B also. And then there's and then the second one is they will execute instruction C and D simultaneously. So that's what's the difference. I mean, not the difference, but the in order execution with limited out of execution works. The Cortex A53 is designed to support the ARMv8 instruction set architecture. It can seamlessly handle both 32-bit and 64-bit instructions, offering enhanced performance and memory addressing capabilities. This compatibility with ARMv8A allows the Cortex A53 to work with a wide range of software and take full advantage of benefits provided by the 64-bit architecture. The Cortex A53 incorporates a hierarchical memory structure to optimize memory access and improve overall performance. It features separate level 1 L1 instructions and data caches per core. These caches are fast on cheap memory stores that hold frequently accessed instructions and data, reducing the time taken to fetch them from main memory. Additionally, the Cortex A53 supports a shared level 2 cache. This larger cache is shared among multiple cores within the cluster. The shared L2 cache acts as a buffer between the processor cores and main memory, storing frequently access data from the L1 caches. This reduces the need to access the main memory directly, improving memory latency and enhancing overall performance and efficiency. So the ARM Cortex A53 supports for ARMv8A ISA and its hierarchical memory structure contribute to its performance and efficiency. These features ensure seamless compatibility, efficient memory access, and optimize data sharing among cores. So the last slide is optional features. First point, the optional features inside the ARM53 is optional hardware FPU for floating point operations. The second one is ARM Trust Zone for secure execution and environments. And so here we have the diagram here that shows the ARM Trust Zone. And then the last one is built-in virtualization support. So I'm at the end of my my explanation for ARM53. So I'll be moving to the next person.
Okay, my name is Ainzuleka binti Albarao. So I will explain about GPU. What is GPU? GPUs have emerged as a significant category of computing technology for both consumer and corporate computers. Next, initially designed for parallel processing, GPU have found applications beyond gaming and are now utilized in various tasks, including image and video generation. Next, GPUs are increasingly employed in artificial intelligence, which is AI, and creative output applications, extending beyond their well-known use in gaming. Their flexibility and programmability have enabled graphic designers to create visual stunning effects and realistic scenarios. Lastly, developers have harnessed the power of GPUs to accelerate workflow in high-performance computing, deep learning, and more. Next. So example of GPU is Apple, Imagination Technologies, Qualcomm, ARM, and this business-grade GPU design that are included into smartphone system on chip. Next. Okay, so in Qualcomm Snapdragon 835, the graphic used are Adreno 540. So the Qualcomm Adreno 540 is an integrated graphic card in the Qualcomm Snapdragon 835 SoC for smartphones. It was introduced in early 2017 and can be found in high-end Android smartphones. Next, the features clearly improve clock speed to 710 MHz and better thermal stability. GPU's frequency 739 MHz. In the reference smartphone from Qualcomm, the Adreno 540 is able to beat or perform at a similar level as the fastest smartphone graphic card on the market. Example, ARM Mali T0MP12, ARM Mali G71 MP8 or Apple A10 GPU. Lastly, therefore, it should be perfectly suited for demanding 3D gaming and also mobile VR and 4K display. That's all from me. I will pass to Wanur Alisha.
Okay, next, my name is Wan Nurul Arisha, and I will present to you about component 3 system cache. So cache memory is a fast and small memory component that stores frequently used data and instruction, reducing the CPU's waiting time for data retrieval from the main memory and improving system performance. So level 1 cache is stores frequently accessed instruction and data for each CPU core, speeds up instruction fetch and data access by keeping them close to the CPU cores, and lastly reduce the need to access lower memory sources like RAM, improving performance. And next is level 2 cache. Provide a larger pool of cache data compared to L1 cache, help reduce the need to access main memory, improving performance, and lastly, facilitates data sharing between CPU cores, reducing inter-core communication and enhancing performance. So as the picture shown in the slide, Cairo 218 efficiency cluster optimization divide to two cores, which is under performance cores and efficiency cores. I will explain more deeply in the next slide. So cache memory in 8 cores of Snapdragon 835. In the Snapdragon 835 system on chip, the Cortex A73 and Cortex A53 core features a level 1 cache hierarchy that consists of separate instruction and data caches. It's important to note that cache size can vary depending on the specific implementation of the ARM Cortex A73 and Cortex A53 core within different SoCs. So in level 1 cache in ARM Cortex A73 performance CPU, instruction cache is 64 kilobyte, and then the data cache is 32 kilobyte. And L2 cache is in Cortex A73 CPU in the Snapdragon A835, which is an L2 cache within the following specification, which is size 2 megabyte. The set of associative is 16 way, and cache line size is 64 bytes. And then L1 cache in ARM Cortex A53 efficiency CPU, the L1 cache instruction cache is 64 kilobyte, and the data cache is 32 kilobyte. For the level 2 cache, the size is 1 megabyte, and then the set associative is 16-way set. This means that each cache can be mapped to 1 to 16-way possible location within the set. So next is cache line. Size is 64 byte. So cache line represents the minimum unit of data that is transferred between the cache and the main memory. So the L2 cache acts as a larger, slower cache compared to the L1 cache, and helps improve overall memory performance by storing frequently accessed data and reducing the needs to access the memory. So that's all from me. I will pass to the next presenter.
So, conclusion. The Snapdragon 835 is another notable generational leap for Qualcomm, and not just in terms of performance or the move to another cutting-edge manufacturing process. There have been improvements across the board for better display, camera, and graphic technology. But most importantly, the Snapdragon 835 set the tone for the next evolution in mobile processing, the move of automation learning, and heterogeneous compute. It also has enhanced electronic image stabilization when capturing video. The 835 is also the first Snapdragon processor to support Ultra HD 4K premium video playback, including HDR10. As we know, newer chip is also faster than older chip. The Snapdragon 835 probably isn't going to set the world on fire with its single-core performance, which seems just marginally better and definitely benefit multi-thread workload. The swing to a 10nm processor will make the chip more efficient while doing the same work when compared to a Snapdragon 821. And Arduino 540 is also very considerably faster than the GPU in the 820 series Snapdragon. That's all from us. Learning is never done without error and defeat, but education is the most powerful weapon you can use to change our future. Thank you. So this is our reference. Next slide. So that's all from us. Thank you. So if you have question and comment, let us know. That's all.